2.6 derivatives of inverse functions. Okay, do you guys remember, like we talked about at the beginning of the year, how do we find an inverse? How to tell if something has an inverse? How to tell if something's inverse is also a function, right? If it's one-to-one, vertical, horizontal line test, all that good stuff. We all kind of remember that, right? Yeah. Okay, more importantly, if I have the domain of F, the domain of F becomes the what of F inverse? The range. And then the range of F becomes the what of F inverse, right? And so remember, inverses are also just reflected over the line, y equals x, right? So think about what this means in terms of continuity and differentiability, right? So I just want you guys to think really quick. So do you guys think if F is continuous on its domain, what do you guys think that we're able to say about F inverse?
On its range.
It's still going to be continuous on its domain.
Okay.
Think about it, guys. So all that's saying, right, if F is continuous on its domain, that means all those y values are true, correct? Which also means that F inverse is also going to be continuous on that domain. Okay? The second thing, okay? If F is differentiable, okay, on an interval containing C, and F prime of C does not equal 0, then F inverse is differentiable at F of C. I had so many absences first period. Very proud of you guys for being here. Especially everybody that was on the Stuco trip all weekend. You guys excited to be sick for the next 4 days? Just start pounding airborne now.
I was sick at the beginning, not good.
You did what?
Never mind, because I was gonna blame you for being sick. But I was sick.
Patient 0?
What?
Patient 0?
Brandon Mosley was patient 0. You were sick like 2.5 weeks ago. Barely. Everybody blame Brandon. Now YouTube's gonna blame you too. No, they did not. Sydney tell you what happened?
Oh my god.
She kind of showed me.
Yeah. Okay. Yeah, okay. All right, so here we go. If F has an inverse function G, that's supposed to be a G. There we go. Then G is differentiable at any x for which F prime of G of x does not equal 0. Moreover, G prime of x equals 1 over F prime of G of x. given f prime g of x does not equal 0.
So why can't
Well, if it's 0, then you're dividing by 0. Are you good over there?
He's judging me because my handwriting isn't the size of the name of the star.
Does he have very large handwriting?
I think you just
Okay.
just like an entire page for you. Look at this, Carol.
They look the same.
No.
Okay. Can we jump in some examples?
Yep.
Okay. All right. Let f of x equal 1/4 x cubed plus x minus 1. All right. So this is we're gonna have two questions, right? So what is f inverse of x when x equals 3? And the second part that we're going to talk about, right, is what is the value of f inverse prime of x when x equals 3. Okay, first things first, right? F of x is 1-to-1 and has an inverse function, right? We could prove that if we wanted to.
Yeah.
Okay, let's not waste the time on that. The first thing that I want you guys to know, okay, is what's the value of f of 2? Just real quick. It is 3. Why would I be asking you guys to tell me what f of 2 is? Because it gave us the answer 3. Does that make sense? So remember, guys, if we want to evaluate f inverse when x equals 3, I'm looking for when 3 is the output of our original function. Does that make sense? Okay, so what could we then say f inverse of 3 is? It's 2. Right? Remember that property of inverses. Are you guys with me? Okay, now for part B, what we're going to want to do is use that last theorem that we just wrote down. Right? So if we have f inverse, the derivative, right, at 3, what this equals is 1 over the derivative of f at f inverse of 3. Okay, what did we just say f inverse of 3 is? 2. Okay, so we get 1 over f prime of 2. Well, we now know how to find this. Do we agree?
Yeah.
So do that. Okay. So what does f prime represent?
The derivative.
F prime represents the derivative. So you probably need to find the derivative and then substitute it. find the derivative first. Is it dead? Henry, was that one dead? Yeah. Thank you.
Yeah. Yeah. Sorry, guys.
Okay, so guys, I heard the same question a couple times. Some of you guys asked, hey, do I substitute this in and find the derivative? Why would that be a bad idea? Okay, so when I substitute 2 into this function, what would we get? We would just get a number. What is the derivative of a constant? 0. That's where that issue is, right? So I don't want to substitute in first. We want to take the derivative first and then substitute. So first things first, what did you guys get for f prime? 3/4 x squared plus 1? Do we all agree with that? Okay. Also, I'm just going to write in some, you're going to start seeing me do this a whole lot, especially when we get to related rates tomorrow, Thursday, Friday. It's just talking about this idea of side work, just for us to organize stuff correctly. Okay? All right. So now we substitute 2 in. You get 3/4 times 2 squared plus 1, which is?
4.
So our final answer, f inverse, the derivative of f inverse at 3 is
4.
1/4.
1/4.
Okay. All right. So this is something that you guys probably should have talked about in pre-calc. If we were to compare the slopes of reciprocal functions, right? So if I have f of x and I have f inverse of x, can you guys come up with what you guys think the slopes would be? Opposite reciprocals? Okay, where does that come up from? Well, that comes from perpendicular lines, right? Which I agree with. So it's not going to be where they are opposite reciprocals, because that's perpendicular lines, and you're really close on that. It's just that the slopes themselves are just regular reciprocals. Okay?
Wait, like, can you give an example?
What's up? Absolutely. I would be so happy to give you an example. Okay, all right, let's go. We're going to start with something relatively easy, okay? F of x equals x squared. And I'm going to explicitly say that x is greater than or equal to 0. So that way I can say f inverse of x is the square root of x. And not plus or minus root x. Right? What kind of graph is x squared? Yeah, what's the shape of a quadratic? Parabola, right? So then, our inverse would look like this. So I want to restrict the domain of f because this is not a function, right? So we restrict it, so I only care about this part.
Okay.
Does that make sense? And it eliminates this part of the parabola. You guys with me?
Yeah.
So that way the inverse itself is a function.
Oh, yeah.
Okay? All right, so what I want you guys to do, right, is show that the slopes are reciprocals at the following 2 points. 2, 4, and 4, 2. Okay, and then at 3, 9, and 9, 3. Having the desks in the house is awful.
I know.
That's what happens with my first period. You know how long it would have taken you guys to put them in groups? It would have taken you 19 minutes.
You're welcome.
That's what I thought. I think we're doing it through different
You don't necessarily have to.
well, yeah, but
Square root of x is the same as x to the 1/2 power. Well, again, it's the reciprocal for the powers.
I just put in more work for no reason.
Right, when we're talking about slopes, guys, our first step is we want to find the derivative of each. Right? So f of x equals x squared. The derivative of f of x then is 2x.
Yep.
F inverse of x equals root x. There's a weird parenthesis on the end that I need to erase. Okay? Annotationally, it's really important that we write it this way. This is saying the derivative of f inverse of x, right? If I don't use the parentheses here, it's going to look like you're taking it to like the negative 11th power, right? Does that make sense? Because ones and apostrophes look very similar. Okay, what do we do from this point? Okay, so I'm going to use 2, 4 for what? The original function or for the inverse?
The original.
The original, okay? So we take that, we go, okay, well, f prime of 2 equals 2 times 2, which is, so remember, guys, this is saying the slope at x equals 2 of x squared is 4. It is just happenstance that the y value of the point is also 4. That's not actually related, okay? The y value being 4 does not matter there. Okay, then what we're going to do, okay, is substitute 4, 2 into the f inverse, right? Okay, so f inverse of 4 is 1 over 2 times root 4, which equals 1/4. What is the reciprocal of 4? 1/4. So does that make sense? We just proved, right? If I think about this, if I'm looking right here, is it plausible on my original function that the slope of this tangent line is 4? And that's just me really quickly sketching, right? Is it then plausible at x equals 4 that the slope of this tangent line is 1/4?
Yep.
That's all that it's saying. Does that make sense? Okay, can you guys do part B on your own? Just verify that it works, if you haven't already. No yawning allowed. you guys play this week? On Thursday? Is that a Denver thing? It's because what? Gotcha, that makes sense. Okay. What time, do you know what time you guys are gonna leave Thursday then?
No.
You do? Okay. So you won't miss this class? Okay. What?
To know is to be able to teach. Is that bar?
Yes. Whatever you say. Okay, what'd you guys get for f prime of 3? 6? What did you guys get for the derivative of f inverse at 9? 1/6. Anybody need me to walk through this? We're just plugging and chugging, we're okay? Okay. Now, your guys' favorite things. What's the last 6 derivatives that we need to memorize? Inverse trig. Yeah, baby. All right. So derivatives of inverse functions. All right, there's 6 of them. So the derivative with respect to x of arc sine of u. So I'm just doing this generally speaking. What are we taking the derivative with respect to? Taking the derivative with respect to x. So what do we know is going to be included then? Not x. U prime. Right? So we're going to take the derivative of arc sine of u with respect to x, but then chain rule states, since I have u, I'm going to have to do u prime, right? So the idea here is this ends up being u prime over the square root of 1 minus u squared. And we're going to do a proof of this because I think it's going to really help you guys see where this comes from. It's going to be short and sweet. The derivative with respect to x of arc cosine of u equals negative u prime over the square root of 1 minus u squared. Do we notice a similarity here?
Yes.
Right?
Cosine equals negative sine, that's why it's a negative, eh?
Right, think about what's the derivative of cosine? Negative sine, right? So that always helped me help keep these straight. All right, the derivative with respect to x of arc tangent u is u prime over 1 plus u squared. We have 3 more. Now, however, these are sometimes tested on the AP exam, sometimes they are not. When they are tested, it is primarily these 3. You notice how I said the word primarily? That still leaves it open to the potential that it's the other 3. However, I would bet my life savings of, the 7 cents that's currently in my checking account that it's going to be these 3. What, Brandon? You calling me poor? That's what it sounds like. Okay. Also, so we're going to do the other 3. Real quick. Arc sine of x. What's another way for me to represent arc sine of x? Sine inverse of x. You'll see both of these. It literally will say, well, I don't know because it's weird hybrid now, but it used to say in your guys' text, the test book, when you take the AP exam, it would say, hey, you're going to see this and this simultaneously. They're interchangeable, right? So be comfortable with us writing both of them. All right. What do you guys think the next one's going to be? Arc cotangent of u. Okay. That is going to be negative u prime over 1 plus u squared. Derivative with respect to x of arc secant u equals u prime over the absolute value of u times the square root of u squared minus 1. You guys can see why they don't test frequently over arc secant. Or arc cosecant of u equals negative u prime over absolute value of u square root of u squared minus 1. Yeah, why absolute value? That's a really interesting question. Let's revisit that after we do this proof.
How did it do this?
One is negative, one's positive.
Oh, I wrote negative.
Also, what's the difference between arctan and arc cotangent? One's positive, one's negative. It's different of arc sine and arc cosecant or arc cosine. One's positive, one's negative.
We did just dance at the end of this
What?
We did just dance at the end of this class.
No. I'm not Miss Gatlin. We don't have time to do Just Dance. I know. There's a reason she quit.
Me?
Yeah. That was actually in her letter of resignation, you specifically.
She gave me a hug.
I bet she did.
One day you got here.
It was pity. All right, we all have these written down? All right. How many derivatives are we up to now?
A lot. I have
24.
Yeah.
24 that we have to have memorized.
And like the very first one was the constant rule.
Yeah, I'm going to post the sheet on Google Classroom for you guys. Okay? I will post, it'll probably be later tonight, but it'll be kind of your cheat sheet of, I didn't want to give it to you guys originally because I need us to know how to actually derive these things. Okay, real quick, we're going to do a very quick proof. Okay. Let y equal arc sine. We're going to prove the derivative of arc sine of x. Okay, I'm going to restrict x to be between negative pi over 2, or sorry, y, okay, to be between negative pi over 2 and positive pi over 2. Okay. Here's kind of what sorry. It's got me sick. Okay. Here's the idea. If y equals arc sine of x, do we agree that sine y then equals what? So if I take sine of y, I have to take sine of arc sine of x. But sine and arc sine are inverses. So that's just 1, which just leaves me with just x. Do we agree with that?
Yes.
Okay. Now, here is the idea, okay? This goes back to your guys' right triangle trig. If this, y is an angle, my hypotenuse is going to be 1, like we're dealing unit circle style. Sine y equals x over 1. Sine is opposite over hypotenuse, right? This is your freshman geometry class. Sine, opposite over hypotenuse, right? How can I find this side right here?
A squared plus b squared.
A squared plus b squared equals c squared, right? Pythagorean theorem. Okay? So if I do that, what does that side right there become?
X squared minus 1.
1 squared minus x squared Square root of?
1 minus x.
Okay? Yes.
They're both square rooted, couldn't you just say it would be 1 minus x?
Nope. Square root of 1 minus x squared. So what you are proposing is to say, oh, this is just 1 minus x, right? What if x is 3? What's 3 squared? So I get 1 minus 9, which is the square root of negative 8, right? Which is 2I root 2. Well, this would just be 1 minus 9, which is just 8, right? Remember, this is grouped together because there's a sum or a difference with it. Does that make sense? Okay. So really quick, let's go back. We have sine y equals x. We want to take the derivative with respect to what? So if we take the derivative with respect to x on both sides, okay? Now what's the derivative of sine y? So we get cosine y. However, we have to utilize our chain rule. So what is the derivative of y with respect to x? dy dx. Beautiful. Equals, what is the derivative of x with respect to x? 1. Okay. So now, as we're going through and we are solving for dy dx, we get dy dx equals 1 over cosine y. Oh, crazy. Now, we go back, we revisit this triangle, right? What is cosine of y? Well, first, cosine relates which two sides? Adjacent and our hypotenuse, correct. What's our adjacent side? 1 minus x squared. Our hypotenuse is 1. So this becomes now, right? 1 over what? One minus x squared over 1, right? Which, what does that simplify to? 1 over 1 minus x squared. If we go back to our shortcut, did we prove what we needed to prove? According to the theorem, right, that I just gave you guys, what was the derivative with respect to x of arc sine u? U prime over the square root of 1 minus u squared? Is that what we just proved? Right? We had arc sine of x, derivative of x is 1, over square root of 1 minus x squared. No, so u would be a function of x, right? So in this case, you're right, we used x. What was x prime? With 1, because the derivative of x is 1 with respect to x.
Let's say it's like 2. Like it's sine 2.
Well, sine of that would be 0, because that's just a constant. If it's x squared, then this would be 2x. This would be x to the 4th.
So you can like, so.
You know what?
I get what you're saying. I just want to.
Well, I'm really glad that you have those questions, because it's crazy. What do you think our next, what do you think the next thing that we're going to do is? Oh, okay. A ruler? Like how small or large? Like a yardstick? Yes. Okay. Examples for you guys to do on your own.
It's hard to learn, like, can you coming up with this? You're trying to explain your new field of math to somebody else, what are you talking about? Math is 1 plus 1.
Oh, yes, this is what I wanted to do. Yeah. No, no, it's like, it's what I was thinking.
All right, work together. Try to catch the pattern.
I think we can actually just plug in our x's is our u's and get a value. I got 2 over 1 minus 4x squared, the square root of 1 minus 4x squared. For a.
Yeah.
I got 2 over whatever you
But that's also reduces to what?
You just have 2 over.
Getting to it.
Two x squared.
Right?
Did you forget to square the 2 in front?
Square root.
Yeah, but you forgot to square the 2 in front of 2x squared and 4x squared. 1 minus 4x.
Oh, I'm just leaving it in parentheses.
I guess.
It's easier to do it your way.
Are you sure?
Yes.
Oh no. Here's a good test. What if we give him another one and he goes back to normal? Or like he doubles it up? It exponentially grows.
You leave that mug.
What do we think of this? Like carving an ice sculpture?
Wait, what, right side of your brain too, right? Spatial.
Oh my gosh, I realized.
Guys, I have an idea.
What side
What
is
if we hook Luke up by his feet? Look, I have an idea. If we hook you up by your feet to a centrifuge, we can pull all the blood to your brain, which means you'll have more oxygen density, which makes you think harder, think smarter. No, I got it. I have this correct.
Hey, Brandon, you
Take half of it. Take out the bad half and slowing them down, the good half and push it too far. I don't know, take one out, make them smarter.
I haven't done it.
Yes, take one half out and make them smarter, leave it, and make them down, and put the other half up.
He's trying to hold in the urge to like,
Not recommend. Worst experience of my life. They didn't even have family guy. We don't watch when they were poking in there.
if he's plugging black.
That's worse. No. I'm saying the Brandon and getting angry like a bear.
He's
3 over 1 minus 9.
No, he was doing math with me earlier.
He's unlocked.
Maybe you're just
Okay, so guys, in A, what is our U? 2x. So this equals, what is the derivative of 2x? 2 over the square root of 1 minus the quantity 2x squared, which is 2 over the square root 1 minus 4x squared. Do we all get that? That's it. That's the answer. You all with me? Okay. Okay. What is our u here? 3x. So the derivative of arctan is u prime, which is what? 3 over 1 plus u squared. What's our u again? What is the quantity 3x squared? 9x squared. They're not terribly difficult, but the struggle's going to be remembering the pattern, right? Okay. What is our u in this case? Square root of x, right? What is the derivative of root x? 1/2 x to the negative 1/2 over, right? The square root of 1 minus x, because x to the 1/2 quantity squared is x. Now we do need to simplify this a little bit, right? I have a complex fraction here, right? So this ends up becoming 1 over what? 2 root x times 1 minus, or the, it'd be cool if I could write, I'm just running out of room. Square root of 1 minus x, which becomes 1 over 2 times x minus x squared. Don't worry, guys, we're almost done. All right, for this next one, what is our u? E to the 2x. Okay, what is the derivative of e to the 2x? 2e to the 2x. The chain rule. If it was just e to the x, it would just be e to the x. Right? Do you guys see now why I killed you with delta math? Yep. And I know that some of us still didn't finish. If you didn't finish, I extended it to Friday with like partial credit. Some of you guys were up at like 12:05. I'm sorry. Did you finish it? Okay, over absolute value of e to the 2x. So, guys, is e to the 2x ever negative? No. Okay, so that absolute value I can drop. So it's e to the 2x. I'll write it so that way when it's in your notes, you guys remember that it's there. Square root of e to the 2x quantity squared minus 1. Okay, which equals 2e to the 2x over e to the 2x square root of e to the 4x minus 1. And then some more stuff simplifies, yeah? E to the 2x over e to the 2x. So our final answer is 2 over the square root of e to the 4x minus 1. Yes?
So e to the 2x is equal to gx. I know, but I don't remember doing delta math.
E to the u is u, or sorry,
Oh yeah, I do.
u prime times e to the u.
Yes.
It's the chain rule.
Yes. So it's just 2x is equal to that up front.
Correct. Okay, one last example and then we're done.
For the day?
Yep. Y equals. It is a very long one. So you'll be able to figure this. So the derivative of this itself is not terrible, but what we're going to end up doing is figuring out a way to reduce it where it's something more nice. So what I would expect for class for the rest of the week is tomorrow we're going to have a section of notes. I don't know if we'll finish it. If we don't, we'll finish it Thursday. But Thursday and both periods on Friday, we're going to be practicing related rates.
What's the homework gonna look like this week?
What's up?
The homework this week?
What about it?
What's it gonna look like?
We're gonna kind of see how it goes.
Okay. You can write assessment.
No, like I know that you're trying to like figure out what your week looks like. I got
Oh
you.
yeah, well we don't have any Wednesday, which is next fine, right?
Correct.
And that's for week 2, so it's less than a week. So
Yeah.
it's less than like a normal week if you add it all together.
Yeah.
Yes.
It's gonna offset somehow. Well, I think last week you guys only had the Delta math.
No, we had
We
2
had
papers.
the problems.
Oh,
we did.
Yeah, you probably would before you leave. Was there bookwork last week?
I know, I was
But you gave us these 2 problems.
No, I told you that we weren't gonna turn those in. Was it only Delta math?
Yes, we got it.
Yeah, okay.
We got it like after class on Tuesday.
Yeah. Okay, that's what I thought. I was like, last week was one big Delta math assignment.
Yeah.
Okay.
You are right, I'm sorry.
The proof was the week before.
Donut monster one.
There it is. Alright.
Can you eat it all in one bite?
I mean, yeah.
Because that's what you should try, like try it.
Tiny compared to.
Oh, I thought you were gonna
Like,
Really good though.
like, mini though.
Really good.
Krispy Kreme never.
I need 3 days to catch up on everything.
When's your next student weekend?
Not soon enough.
When's the break again? Was it like a month, fall break?
Yeah, fall break sometime on fall break.
It's like how.
What's that, fall break?
Fall break.
Do we agree that's the derivative of arc sine of x? What do we have to use for the next part? Product and chain rule. Okay,
How do we know that we use product and chain rule?
because it's x times the square root of.
Oh, I see, I thought you were doing something.
Okay, so what's the derivative of x?
1.
Times 1 minus x squared. Do we agree with that?
Yeah.
Okay, plus x times what's the derivative of 1 minus x squared? Well, the first, what's our big function? Root, right? So you get 1/2 times 1 minus x squared to the power of negative 1/2 times what's the derivative of the inside? Negative 2x.
Wait, 1 minus x.
Okay. All right, so let's kind of simplify, see what this looks like. We get 1 over root 1 minus x squared plus the square root of 1 minus x squared plus, well, is it plus? Ends up being minus, right? Because you should get what? Negative x squared over square root of 1 minus x squared. Do we agree so far?
We're having those. Yeah. I'm focused on running it faster, understand?
X times 1/2 is x over 2 times negative 2x becomes negative x squared. This thing's raised to a negative power, so that just goes to the denominator. Right?
Yeah.
Okay, is there a way for us to simplify this at all? Okay? How do we simplify it at all?
First and the third fraction was subtract each other.
So we get 1 minus x squared over the square root of 1 minus x squared plus root 1 minus x squared. Do we agree? Well, you guys notice how these two things match? What is this quantity raised to a power of? 1. So what does that simplify into? Nope. When you, so it simplifies to 1 minus x squared to the 1/2, which is just the square root. Because what's 1 minus 1/2? 1/2. Here, let me write. Right, this is to the 1/2. Yes, no? Okay. Plus root 1 minus x squared. Do we all agree that this is really just the square root? Which part?
How did you turn into that?
Because this is to the power of 1. And to get from here to here, it's 1 minus 1/2. Because when we're dividing the same base, if I have something like x to the a over x to the b, that's x to the a minus b. This whole thing is to the first power. This is to the 1/2 power. 1 minus 1/2 is 1/2, right? So this is really, this whole thing is to this root. So I have the same roots added together. This becomes 2 times the square root, 1 minus x squared. Okay, that's it. That's all I got. That clock is fast by like 3 minutes, so you guys still have like 13 minutes left. Do with that with what you will.